University of Milan, and today I'm going to present my point of view of how I'm integrating computer vision in my PhD research. Nowadays, artificial intelligence is rapidly evolving in construction sector. However, its adoption is everyday practice, and the practice is still limited, especially among small and medium enterprise. In the safety domain, most computer vision research focuses on hazard detection or continuous monitoring using cameras. But routine inspections instead are still carried out manually. They are mainly dependent on the experience of the health and safety manager and on fragmented documentation. And this creates a gap between technology already available and the way that inspections are actually performed on construction site. To introduce our proposal, it is important to understand how a routine inspection is performed today. We have two main actors, the H&S Manager, the inspector, and the contractor. During a site walkthrough, the Health and Safety Manager inspects the construction site area by area. And for every observation, the manager compares what is happening on site with the safety requirements defined in the project documentation. At the end of this assessment, each observation is classified into one of three possible outcomes. The first is compliant, and it meaning that the observed condition fully satisfies the safety requirements. Then we have partially not compliant, and this means that some requirements are not fully respected, but the situation does not represent an immediate danger for the workers, but correction are still required. The third category is critically non-compliance. In this case, the violation represents an immediate safety risk and may require stopping the activity or restricting access to the area until the problem is solved. This classification is central to the inspection process because it determines the following actions. Most importantly, this evaluation always remains to the responsibility of the health and safety manager. Based on this context, our objective is to provide a structured basis for integrating computer vision into routine inspection. To achieve this, we first formalize the current inspection using BPMN 2.0. This allows us to identify the activities, the actors involved, and the information exchanges and the decisions point. Once the current process is clearly represented, we can identify where computer vision can support the inspection without changing the responsibility of the health and safety manager. To describe the inspections, we use the process model and business process model and notation. BPMN is a standard language for representing processes, and instead of describing software, it describes how people perform activities, exchange information, and make decisions. In our case, BPMN helps to transform an inspection that is usually based on experience into a structured and explicit workflow. This also makes it easier to understand where digital technologies can be introduced. In our methodology follows three steps. First, we model the current inspection process. Then we analyze in detail the most repetitive task, which is the inspection of the future of interest. And then we proposed an enhanced workflow for computer vision support. Okay, this is the first BPMN, and represents the complete inspection process from the perspective of the H&S Manager. This inspection is based on an Italian context and starts by creating a new inspection report and reviewing any pending issue from previous inspections. The H&S Manager then performs the site walkthrough And for every feature of interest, compliance is assessed. If no issue is found, the inspection simply continues to the next observation. If a non-compliance is identified, the contractor is notified and the corrective action are requested. Some issues can be corrected immediately, while others remain pending and will be verified during a future inspection. Critical non-compliance may also require stopping the activity and until the unsafe condition has been removed. Finally, the inspection report is completed, signed, and archived. The BPMN diagram makes this entire workflow, as you can see, explicit and clear it clearly shows the responsibility of each actors. If we zoom on the feature of interest, the yellow box in the previous slide, here we have the model of the complete process, and we focused on the most repetitive activity, which is the inspection, of course, of the feature of interest, the FOI point. Every observation during this site walkthrough belongs to one of these three categories: the ongoing activity, site layouts, and workers' equipments. The first category includes the ongoing activities and the permits of authorization required to perform them. The second one concerns the site layout and including collective protections, access routes, and safety signage. The third one includes workers and equipments together with training records and machinery documentation. During the inspection, the manager evaluates these three categories and compares them with the project documentation in order to record the corresponding observation. Once the process is represented using BPMN, several limitations become evident. Inspection results depending strongly on the experience of the individual manager. Features are usually assessed independently, making it difficult to identify recurring problems. Observations are recorded as free text. Photographs are often stored separately from the related observation. Reporting is manual and time-consuming. And finally, documentation is fragmented across different repositories. This limitation reduces consistency and make the integration of AI technologies much more difficult. To address this limitation, we propose a computer vision decision support, and the inspection workflow remains exactly the same. The difference is that the manager can now capture a photograph using a general mobile device. Computer vision recognizes the relevant elements in the image and generates structured metadata. These data are connected to health and safety knowledge base containing project safety requirements, contractor documentation, previous observation, and corrective actions. Based on this information, the system prepares context-specific observation suggestions, and then it is important to underline that the system only provides suggestions. It never decides whether an observation is compliant, partially not compliant, or critically non-compliant. The final judgment always remains under the responsibility of the health and safety manager. This is the final BPM diagram where the decision support system is integrated in the workflow. Compared with the previous one, new activities appear after taking the picture. The image is analyzed using computer vision, and the recognized objects are linked to the knowledge base. The system retrieves the relevant safety requirements and generates observation suggestions, and after reviewing this suggestion, the manager performs the compliance assessment and records the final observation in a final report. In this way, the workflow becomes more structured without changing the decision-making process. This proposed approach can also be interpreted from a human data interaction perspective. First, improve the legibility, the agency, and then it supports the negotiability. Future work will focus on 4 directions. First, evaluating different computer vision approaches using under variable construction site conditions. Then, improving the structural management of visual evidence within knowledge base. And the third one is about addressing privacy and data governance issues related to construction site images. And finally, we would like to improve interoperability between inspection data, project documentation, and safety regulation, which is actually the main topic of my PhD. Thank you for your attention. I'm sorry if I